Hello everyone, welcome back. This is Dr. Sunitha M, working as Associate Professor in Marri Laxman Reddy Institute of Technology and Management. As we have studied in the previous session about the compilers and how is the existence of a compilers. Now today we'll study about a lexical analysis. Okay. In this session we are going to study about a lexical analysis. So, what is lexical analysis? So, lexical analysis is nothing but what it is a first phase of a compilers. So, compilers are what which is used to convert a high level language into a low level language using the compilers. Right. In the same way, the lexical analyzer, which is the first phase of a compilers, as in the compilers there were 6 phases. So here lexical analyzer is the first phase of the compilers, which is also called as a linear analysis or a scanning. So streams of a characters or a statements which make up the source program, okay, that need to be read from left to right and grouped into a tokens. So that are the sequence of a characters having a collective meaning. Okay, see here the block diagram which consists of a lexical analyzer, parser and a symbol tree. Okay, initially a source program enters into a lexical analyzer. Okay, so lexical analyzer which reads a statement or a character by character. Okay, it sends a tokens. Those characters are nothing but called as a tokens. That tokens are given to the parser. Okay, so those tokens are given to the parser. So parser here what it does, it takes those tokens and again send back a message to the lexical analyzer to send the next token. Okay, so parser sends a message asking that send the next token. So lexical analyzer, after receiving the next token message, it sends a token to the parser. So all the tokens which enter into the parser in this form repetition of a tokens. Okay, from parser to the lexical analyzer and from lexical analysis tokens will be sent to the parser. So all these forms a parse tree. Okay, so syntax tree or a parse tree. So using these tokens we can form a parse tree. And again here symbol table is used. So lexical analyzer and a parser, these two are dependent on a symbol table. So what is a symbol table here, which is used to store whatever the identifiers or else types of identifiers, all those are saved in a symbol table, which is used to retrieve immediately whatever the data we want to retrieve or else we want to check by the compiler. Okay, compiler, it retrieves the data as if it might be an identifier or it might be a types. Okay, those can be retrieved easily without any wastage of a time. Okay, so the process of taking an input string of a character such as the source code of computer program and producing a sequence of symbols okay, that is nothing called as what, lexical tokens or just tokens. Okay, which may be handled more easily by the parsers. So parser, it takes or collects all the tokens given by the lexical analyzer. In the previous block diagram we have seen that parser collects all the tokens, okay, which are coming from the lexical analyzer, that is from the source code. Okay, so the lexical analyzer reads the source text and thus it may perform certain secondary tasks also. Okay, the main task is to take the tokens from the parser, it takes the token from the lexical analyzer. Okay, so again this lexical analyzer, it performs a certain other task like eliminate comments. Okay, it eliminates comments and the white spaces whatever are present in the line or a code. Okay, those it eliminates in the form of a blanks. Okay, what it takes in the form of a blank or a tab and a new line characters or any comments are given, that also will be eliminated by this lexical analyzer. Next, second is correlate error messages from the compiler, okay, with the source program. It relates all, keep track of all the number lines of whatever the code, everything is there, that keeps track of each and everything. Okay, token here. So what is token first? A token is a group of characters having collective meaning. Typically, it might be a word or character or any punctuation marks separated by a lexical analyzer and passed to a parser. So, a lexeme. Next, a lexeme is nothing but what actual character sequence which is matched with a pattern of a token. That is nothing but called as a lexeme. So, pattern here is nothing but what a rule that describes the set of strings associated to a token. So expressed as a regular expressions and describing how a particular token can be performed. So pattern here indicates that rule where we need to follow. Okay, it might be in the form of a pattern or any symbol, anything that we need to follow. So the pattern matches each string in the set. Okay, or else expressed as a regular expressions and describing how a particular token can be performed. Okay, so a lexeme is nothing but what a sequence of a character in the source text that is matched with a pattern for a token. Okay, so for example, if we take as int value is equal to 100 semicolon. Okay, what is int here? It acts as a keyword. So these all contains tokens. Okay, inside the tokens again this specific consists of a keywords, identifiers, any punctuations or any constant values. So all this we'll know in this here int. Okay, int we'll take it as a keyword. And what about the value? Value here acts as an identifier. And what about a equal here? Equal to sign acts as an operator. And 100 here is a constant and semicolon acts as an punctuations or else punctuations. So here int is a keyword, value is identifier, equal to is an operator, 100 is a constant, and symbol. 100 is a constant or a and semicolon it might be a symbol or any punctuations. So specification of a tokens here, how we are going to specify the tokens. Okay, so let us understand how the language theory undertakes the following terms. Okay, how these alphabets are going to specified in our program. So any finite set of symbols like 0 comma 1. Okay, usually we'll use 0 comma 1 or else a comma b, and it might be a capital letters or a small letters, lowercase letter or uppercase letters, or is the numbers from 0 to 9. Okay, so 0 to 1 if we use it is a set of a binary alphabets, and 0 1 2 3 till 9 and capital A B C D E F is just a set of hexadecimal alphabets, and lowercase A to Z and uppercase A to Z is set of a English language alphabets. So here the tokens, and lexeme is what did I say, sequence of a characters which is matched with the token of a pattern of a token. See here, so token here is a constant, lexeme is again a constant, so description of that pattern is constant. So if, okay, lexeme is, we'll take it as if itself, so description is if. Relation here, what are the relations? Okay, in our code, relations or else operators we are going to use, what are those? So lexeme is here is less than, equal to, greater sign. Okay, then id. Okay, token here is id, but lexeme for that can be pi, count, d2. Okay, and then next number. Token, if the token is a number, what will be the lexeme for that? Like 3.142 or a 0.6, 6.22, any. Okay, this is just a constant number. Okay, pi value or any count number like that. Okay, next literal, that is code dumped. Okay, literal, so lexeme is a code dumped. It can be any character between and except. Okay, so here lexeme again, let us study about the what is lexeme. So lexeme is nothing but what, a sequence of a character that is matched with the pattern of a token. Okay, that character is matched with the character of a token. So here exact definition might be, a lexeme is a sequence of a character in the source program that is matched by the pattern for a token. Okay, when more than one pattern matches a lexeme, then what we need to do? So the lexeme has to provide additional information about that particular lexeme. Lexical analyzer that has to provide more information, that is additional information of that particular matched or else particular lexeme. So the lexical analyzer collects information about the tokens into their associated attributes. So in practice, like a token has usually only a single attribute, a pointer to a symbol, table entry in which the information about the token is kept, such as the lexeme, the line number on which it was first seen. See here the example. Int add. When a source program is given, the lexical analyzer start analyzing the code. Okay, so here example here they have taken is int add. Okay, open brace int a comma int b. So the source code starts analyzing here, that is the compiler lexical analyzer will start analyzing int. So int, it acts as what? A keyword again. After keyword, after that is int, a space is there. Okay. So what lexical analyzer will do with the space? It eliminates, because a lexical analyzer, why any white space, any this thing, comment lines are there, that will be automatically deleted or that is eliminated. So it won't consider the white space as a token. So add is there, that acts as an identifier again. So next, open brace. Okay, open brace again, int acts as a what here? Identifier. A, int is a keyword, a comma int again b, open brace. So how many tokens are here? 1 2 3 4 5 6 7 8 9. So in the first line of the code there are 9 tokens, because space is not taken as considered as a token by the lexical analyzer. Next line is a comment line, that is adds 2 numbers. So automatically this lexical analyzer, it eliminates the comment lines also. Open brace again, int c, int is there again, there is a space is not considered as a token, so again c is there, then semicolon. So 1 2 3. So token, here are 3 tokens. Next, c is equal to a plus b semicolon, return again 1 2 3 4 5 6 tokens. So in a particular line there are tokens, the number of tokens again we need to know. Then return c is there, 1 2 3, then close the brace. Just see here once. So there are total 23, right? 23 tokens. Okay, from the starting int to the ending there are 23 tokens. See here, int, we are considering it as a keyword, token, keyword, add as an identifier, punctuations is open brace, int is again a keyword, a is an identifier. In the previous here itself, so int, what did I say? Int is again what? Keyword. See, int is keyword, add is identifier, open brace is again punctuations, int is again keyword, a is again identifier, comma, that is punctuations again, int b. So all these are identifiers, keywords. Okay, how many tokens are there? 23 in this. Okay, next, the role. We are going to study about the role of a lexical analyzer now. So what is the role of a lexical analyzer? So lexical analyzer, what did it say? A character statement or a character by character we are going to read in the lexical analyzer. So here cleaning up of a source code. So what cleaning up of a source code? Source code often contains extra characters, right? So for example, here itself a space is there, right? So that has to be removed. So here they have used as cleaned. Okay, so source code often contains extra characters that the compiler or the interpreter doesn't need, like spaces, tabs, new lines, and comments. So comment lines are also eliminated. It won't consider the comment line also as a token. Okay, so the lexical analyzer removes all this to make the next stage of a processing easier. So think of it like cleaning up your desk before starting a project. So we can think when we want to start a new project. Okay, we will think it as to clean everything which was presently stored, to clean up first. So clean up the source code. So wherever that is space, or else any comment lines, or else any new lines are there, that has to be eliminated for the next stage of processing easier, to make the process easier. Next, keep track of errors. If any errors will occur, we should go on keeping tracking of all those things, because when we run a particular first, okay, while cleaning up, the lexical analyzer might encounter invalid character. Okay, invalid character, a sequence of a character that don't form a valid token. Okay, so an invalid character can be anything. Instead of int a, if we type it as itn, so that is one invalid character, right? So that has to be that errors will occur. Okay, we get an error if we type it as itn. So encounter invalid characters, or a sequence of a character that don't form a valid token. So for example, it might find a character that's not allowed in the programming language. When this happens, it reports an error message and ideally pinpoints the location of the error in the original source code. Like, if any error is there while running a code, if we get an error, particular line is also specified. Okay, line number and character position also. So this helps the programmer find and fix the mistakes. So if we get like this, if any errors or any mistakes if we do in a particular line or a particular code, that will be identified by this lexical analysis. So keep track of errors. So all these will keep tracking of all those things. Next, figure out the basic building blocks. Okay, to figure out, okay, this is a core job. The lexical analyzer scans the cleaned up source code and groups characters together into a meaningful unit called as tokens. So these tokens are fundamental building blocks of a program. So examples of a tokens include the lexical analyzer doesn't understand the meaning of these tokens. Okay, sometimes it won't understand. So it just identifies what they are. At that point of consideration, it just identifies what they are. So your keywords can be if, else, while, for, int, float, etc. So these are the reserved words with a specific or a special meaning, okay, which we are going to use in our programs. Next, like identifiers are variable names, function names, that is user defined names. It can be operators are a plus, minus, star, is equal to, greater sign of, okay, or less than sign. Literals are numbers, like example 10, 3.14, or else strings like hello, boolean values, true or false, etc. Okay, punctuations like colon, semicolon, open brace, flower braces. Okay. Next, read the source code character by the character, because the role of a lexical analyzer is to read the source code character by character, or it has to read the whole statement character by character. So lexical analyzer reads the source code one character at a time. Okay, it reads only one character source code, one character at a time, grouping these characters into tokens. So it's like reading a sentence word by word, but at a more fundamental level, character by character, to form the words tokens. So this character by character reading allows it to recognize even a complex tokens. Usually it will read character at a time, but reading the statement character by character, it allows to recognize even more complex tokens. Errors, again lexical errors. So lexical errors are the errors thrown by our lexiler when unable to continue. Okay, when it is unable to proceed, we'll get an error. So which means that there is no way to recognize a Lexeme. So lexeme is nothing but what? It is a sequence of a character that is matched with the pattern of the tokens. Okay. Which means that there is no way recognized a lexeme as a valid token for our lexeme. So syntax errors on the other side will be thrown by our scanner when a given set of already recognized valid tokens don't match any of the right sides of our grammar rules. Okay, right sides of our grammar rules. So simple panic mode error handling systems requires that we return a high level parsing functions when a parsing or a lexical error is detected. Next, error recovery actions are what we'll do when these errors will occur. Okay, we need to rectify it, right? To run a program, if we get any errors to that particular line or a particular character, that is position, we need to remove all those and run the program without any errors. So first what we need to do is delete one character from the remaining input. Okay, after deleting one character from the remaining input, what we will get, we need to check that. Next, insert a missing character into the remaining input. Okay, whatever it is missing in that particular line of a code, we need to insert. Replace a character by another character. If that character is not the correct one, then replace it with another character. Transpose two adjacent characters. So these are the actions that has to be taken when errors occur in a lexical errors. That is lexical analysis. Next, stages of a lexical analyzer. What are the stages? See here, how many stages are there? 5 stages. So what is the lexical analyzer? Which is the first phase of the compiler which performs several stages to convert a source code into a streams of a tokens, right? How it is going to read? Statement, how the statement is read? Character by character, which is used to form a tokens. So these stages include input processing, tokenization, token classification, and output generation. So first let us study about input pre-processing. So this initial stage prepares the input for a lexical analysis. It involves tasks like removing white space, comments, and other irrelevant characters from the source code. Okay, so the initial stage, input pre-processing is what? Pre-processing. Before starting any work, we should study about that work first. So that is nothing but what? Pre-processing, input pre-processing. So first we should initialize the preparation for the input. Preparation of the input for the lexical analysis. So if any white space or any comment lines are there or any irrelevant data is present in that particular line, that has to be removed. Next, tokenization. The core of a lexical analysis, tokenization involves breaking down into stream into a sequence of tokens. Okay, tokenization involving breaking. So whatever the line of a code is there, that has to be break into input stream sequence of a tokens. So a token is nothing but what? A meaningful sequence of a characters that compiler can understand. If a big line of a code is given, okay, we can that cannot be easily understandable. So that has to be divided into a different parts and run each part, then we'll understand whether it is going to work or not. Okay, at a time if we run a big code, if we get any errors, then again what will happen? Waste of time, right? So hence we need to divide or break that sequence into a different sequence or characters that easily compiler should understand, such as keywords, identifiers, operators, punctuations, again marks, and literals here. So that is numbers or strings. So in whichever form it is, that has to be divided into parts, that is sequence. Token classification. How we need to classify the tokens given. So each identified token is then classified into its respective type. So which type of a token is that? That we need to understand first. So for example, int, float or if would be classified as a keywords, right? So first we need to identify all those keywords. So while X, Y or a variable name would be classified as identifiers. So first know the difference between a keyword and a identifiers, right? So int, float, if, all these are what? Keywords. But whereas a, add, subtract, x, y, multiply, divide, all this comes under what? Identifiers. Or else age, build, all those comes under identifiers. So numbers and operators are also classified accordingly. So this is the way we need to classify the tokens. Next, token validation. So validate the tokens. So the lexeme, the actual sequence of a characters that forms the tokens, is checked against the rules of a programming language to ensure whether it is valid or not. Okay, we need to check the particular lexeme is a valid lexeme or not, or else a particular token is a valid token or not. So for instance, an identifier must start with a letter, right? Identifier should start with a letter and can contain alphanumeric character and underscores. Okay, always identifier should start with a letter. Next, output generations. So output generation is nothing but what? The output of the lexical analyzer, that is which will be in the form of a tokens against with their types and corresponding lexemes. So here finally the lexical analyzer outputs a list of a tokens along with the types and corresponding lexemes. So this token stream is then passed on to the next phase of the compiler, that is the syntax analyzer or the parser. That is, see, first lexical analyzer is there, right? So the source code is given to the lexical analyzer. So lexical analyzer forms in the form of a character by reads in the form character by character in the form of a token. So those token is given to the parser. Again from the parser it sends back a message to send a next token. Okay, till that particular token is not identified, till that time it is going on sending the messages. Okay, till you get a correct token. So if this form is repeated, so the parser it will form a parse tree or a syntax tree. So this is the output of this lexical analyzer. So this is the end of lexical analyzer. In the next session we'll be seeing with the next topic. Thank you.